Hello all, my name is Arijit.
Hi, I'm Ritesh.
Today we are discussing about the project that we have done for SQL NoSQL course. In this project, we have selected a data set for breast cancer patients in US. It seems like there are a lot of cases that are coming up nowadays with respect to this, and almost like 1 out of 8 women are actually having this risk of developing breast cancer. Um, and from a diagnosis perspective, if a patient is identified having this particular disease within 5 years, there is a high rate of the patients to be cured. And if it is within 10 years, it is almost having 80% of the chances to be cured. And so, bottom line is, if this cure can be found as soon as possible, this can be treated fairly well, and the patient can be cured fully. So we have taken this dataset as a challenge for us to see how the predictions can be done for the future patients or the details that are coming in from the dataset. This dataset is having 699 records, and this is real-time data that we have tried to explore. During this work, we have done a lot of activities with respect to our data identification, how to mimic the data, the real world data for these patients into our database, how to create the tables, how to insert the data into the tables, how to do the data analysis by finding out the missing values, and how to treat the missing values so that we don't lose our predictions with respect to the actual predictions that is already there. We have also used Python code for visualization, and also for querying critical scenarios with respect to the high prone cases or scenarios to identify the data.
So this dataset consists of almost 10 numeric features, which actually are predictor variables, which helps us predict whether the case can be categorized into malignant or the benign cancer cases. So the important cell properties are captured in this dataset, like clump thickness, the code number, the cell size uniformity, the cell shape uniformity, marginal adhesion, epithelial cell size, bare nuclei, um, chromatin, bland chromatin, normal nuclei, and mitosis. So the sizes of the cells and the different medical properties of these cells are captured in the data set, which actually helps us predict the categorization of the case in under which woman will fall into, what probability it is for that woman to have malignant or benign cancer. So this data set, we took this data set, we from the UCI, as Arijit mentioned, we uploaded into the MySQL database, and then we created tables so that we can analyze different properties and explore, do some exploratory analysis on that for our project. So we divided this into like four tables: the cell control, the cell shape, the classification, which is actually a prediction of our output variable. And then we have a bare nuclei audit table where we are auditing whenever if someone is changing any values in the data set. Let's say in a laboratory, the results were updated for some reason. Then we have an audit of what property was updated and when it was updated.
So in this analysis and implementation, the tools that we have used is through Python Notebook. We have Python 3, which we have used to connect with the database, and the database that we have used is MySQL database. As Ritesh mentioned, we have done the design, and we are trying to use Python right now to create the tables and load or insert the data into the So as we wanted to mimic this data set close to the real-time data, so we have taken the data set, we have done the modeling on the data set, created the tables in the database in the design, and through um, MySQL connector, we have done the connection with the MySQL database. We established the connection. We stored the connection into the cursor, and then cursor is actually used to execute any of the SQL query in MySQL database. So we have first created the database, um, with breast cancer DB, which will be a schema in MySQL database, which will be holding all the tables that we'll be creating after the database is created. So, as per the model, we have created all the three tables, which will be having the data into them, and which will be used for our analysis and further predictions for the classes to identify which woman will have benign or malignant cancer based on the clustering of 2 and 4, which has been 2 has been given for benign and 4 has been given for malignant. Those data will be retrieved out of these tables. To insert the data into the database, we have created the CSV files for declassification, with the name of declassification, which will be used to store the IDs and the classes of the patients. Then we have cell control, which will be talking about the what are the biological properties of the cell, and how they will be tied to the IDs of the patients. Then we have a cell control. We have the cell shape, um, which will be having the size and thickness of the cell. So that table will be created, and we have a respective CSV for that created, and we have used Python to be the front end, which will be interacting via the connectors with MySQL database, and will be inserting the data within the tables.
As you mentioned, after the data is inserted into the database, we started analyzing, doing some exploratory analysis on the different features so that it helps in a better prediction. So we read the data using the same connector through the Python, and then we displayed the data. After displaying, we went down, we started exploring and looking at the statistical properties of that data, of every feature in the database. And we further also wanted to see if there is any relation or correlation between the different features of the data. That would definitely help us in creating a model and increasing the probability of our prediction. So once we have the data, we read the bare nuclei data. We started first. The first step we took is to see if there is any missing data in any of the features which are there in the data set. Once we figured out, okay, there is bare nuclei column that has the missing values of the data, we we started filling that data with the it had the question mark, so we need to replace that with 0 so that it can be utilized for our prediction. Uh, Once we replace that missing value with 0, our data set was ready to be explored further and for our analysis.
So based on the data fixing that we have done, or missing value identification and the fixing with the 0, we have done some further analysis to see what are the critical conditions that the dataset has for the patients, for the scenarios that we have thought can be a little bit more important and explanatory, will be with certain conditions for bare nuclei and mitosis, where you have a normal nuclei and you have malignant. where you have different shell shapes. So we have tried to find out the data with respect to the thickness and uniformity of all the cells and the shapes. So that's goes back into the database, fetches the data, and we are displaying it on the Python notebook.
So once we did that analysis, we started thinking about, okay, which are the features which are more important in, or are there any features which are more important in determining the malignant or the benign? So for that, we had to do some correlation analysis on all the features. So we plotted the correlation analysis of every feature, and we saw there was not much correlation between, which was good. If there was a correlation between the feature itself and our output variable, but there is less correlation between the feature among themselves. As this plot shows, we can see clearly the diagonal histogram uh, are highly correlated, whereas the other than the diagonal data, scattered data, which we have plotted here, are not correlated as such. So all these features are contributing in malignant or benign feature, but they are not correlating with each other, which is good for our prediction. So once after doing the correlation analysis, we did predict. We took the data set and we started classifying using those features into malignant or benign category. We predict so that like as Arjit mentioned, we categorized few cases into two, cluster 2, and the other is cluster 4, which represents malignant and benign case, malignant and benign cancer. So
So this is a screenshot of the database we have created on MySQL. This is a local database which we have created, and these are the schemas and the underlying tables within that. For future scope, we have right now in this project, we were able to insert, retrieve, update the data. In future, we would like to maintain the history of the predictions. So once you get the data retrieved from the database, you do massaging on the data, you combine it, you replace the missing values, you can do the predictions on it, and then you can store it back in the database, and you can use it for further or future analysis and comparisons with the next set of predictions that can happen on the future data. That will be our future scope. Conclusion wise, what we have seen by implementing with MySQL is the connection was fast, the data was retrieved fast, uh, and also we have seen that with the prediction model that we have used, k-means for clustering between malignant and benign uh, uh, categorization. The accuracy was okay, but we have a poor initialization in the k-means, so probably the k-means need to have a better initialization, and I think they have developed k-mean plus plus for that, so that will be again will be used with the future what we have. For reference, we have gone through Kaggle website where this dataset was available, and some of the previous work was already done on this dataset, which actually helped us in come to the conclusion. I hope you enjoyed this video. Thank you so much for watching.
thank you so much.